ordinary least square or LS estimation. So also like other testing procedures, we need to fulfill the requirement of each of the techniques, each of the procedures. In the OLS, the requirement either all variables are integrated of order 0. That means you test the variables and they are stationary at the level. So with that, you can go ahead to do your OLS. If your variables are all I1, each of them are stationary after taking the first differencing, then they are all I1. So what you need to do, you need to do co-integration, and you must find that they are co-integrated. So this is one requirement. Two requirements must be met. Then you can do perform the OLS estimation. Otherwise, if you don't fulfill the requirements, then your results are not reliable and it tells us different story. Okay, not the actual story. That's why in time series data analysis, you need to do this stationarity test, stationarity test, the basic requirement. And for this OLS, you have to top up with co-integration. Now, related to our real interest rate data of the 4 countries, we have shown that they are all I1 variables. We have also shown that there are long-run relationship between the 4 variables. Therefore, we can continue to do ordinary least square without any misleading findings. Ordinary least square. So let's say I want to know this movement of this variable y at the time t. Okay, so y may be the real interest rate of one country. Let's say UK. UK. And so y I can put UK here. Okay, I can put UK here. Normally we put y of the UK here. Or you just use other symbol. UK is y. US real interest rate is S. Germany interest rate is G, and that is also possible. That will simplify your symbols. Y is equal to a constant, so a constant plus another constant times Canada real interest rate plus another constant. C, I don't want to use that, so I omit it. I use D. Okay, multiply by, let's say now is the UK real interest rate plus E, we omit that one. We use F. Okay, F, and then multiply, F is a constant, multiply by US interest rate. So I put this S and plus E, I use it here. Okay, E is an error term. Okay, you want to know the value of your YT, which is here UK real interest rate. It depends on the values of other interest rates. Canada interest rate, this UK interest rate, US interest rate, and YT will not exactly follow the movement of these other interest rates. So sometimes it will deviate a little bit. So we can capture that one by this ET, we call that error term. So error term sometimes is positive, sometimes is negative. On average is 0. Okay, on average is 0. Now, so what do we mean here? What do we mean here? So that means if I have a value of the Canada real interest rate, okay, it will have impact on the UK interest rate by how much? By this factor B. B is a number. All these A, B, C, A, B, D, F are numbers. They are the numbers that we want to estimate when we do OLS estimation. We are actually estimating the numbers for the symbol. Okay, we call it coefficient here. Coefficient, the symbol before the name of the series, coefficient. So let's say this is 0.1, 0.1. And this interest rate is 3. So what is the impact? It will add 0.3, which is 0.1 times the 3. Part of the values of this YT come from here, 0.1. Let's say the D is 0.2 and Canada interest rate is 4. So this is add. And this is, let's say 0.1 again. Okay, the value in the USD, the real interest rate may be, let's say 3%, so 0.3. Of course, you estimate this, there will be certain numbers, also without the presence of other countries' interest rate. US itself also, UK itself will also have its policy to have some interest rate. On average, it will have some interest rate. Maybe this is 3. So 3 plus. And let's say there is no error. Even if you have error, you just top up with the error. Assume there's no error, plus 0. So you will get 3 plus 0.3 plus 0.8 plus 0.3, which is here is 1.6. So you get 4.6. So here you estimated it. You put the cap here, the cap to show you have estimated the UK interest rate based on what has happened in other countries and their influence. Okay, so it's 4.6 at the time T. T is the current period. Let's say 2023. 2023 January, for example. So that is the purpose of estimating OLS. Okay, OLS. You want to know how the value of one variable, time series variable, is affected by the values of other variables through the different channel, okay, that will transmit the impact to the Y. This is time series. For ordinary least square, if it is cross-sectional data, also you can estimate it using the same OLS, not an issue. Okay, across sectional, you can do that. Also, you will estimate the value of the Y based on the value of other variables plus their influence. So this B is telling us the impact. So we normally say the impact of real interest rate on GDP. Then this is your GDP. Interest rate increase, then it will have influence or impact on the value of the GDP. Okay, you want to find the impact. That is one objective, major objective of estimating the OLS. As compared to correlation or co-integration, they will show that two variables or more than two variables, whether they are correlated, positively correlated or negatively correlated in terms of this correlation, and in terms of co-integration, whether they have long run co-movement. Then if that is your objective of your study, if you want to find the impact, if US increased the interest rate by 0.5%, how much UK will increase the interest rate? Of course, this one, we assume there is a relationship. We have to test for co-integration, that they have relationship, that they will move at the same time. When US increase the interest rate, UK will also increase the interest rate, but increase by how much? Then we talk about the impact. So increase by how much? Increase by this much, okay? Multiply the increment, multiply by the coefficient here, okay? The coefficient here that shows the impact, okay? So coefficient shows the impact. So you want to know the impact. If your objective of the research is to find out the impact of COVID-19 on the United States stock market, then you use OLS. If your research objective is to find out whether there is any long-run relationship between interest rate and GDP, then you use co-integration. So it all depends on what you want to examine. Then your techniques is different. We will say more about the OLS later on. So OLS, we have our data here, the few countries data: Canada, Germany, UK, US. So what you do here, when you want to perform ordinary least square estimation, you go to quick, all right, estimate equation, and then you type the variable there. Your variable, the Y variable is in front. Y variable like UK, a spacing, C. This C is our A there just now. C here is constant, must be C. Don't type A here. It is fixed in this the computer language understood by EView is type C. Don't type Y, don't type other, unless your variable UK you change to Y. If it is UK, name as UK, put UK here. And C is constant, the one that is intercept, Y intercept. And put all the factors there, all the factors. So Canada, exactly the same name, US, Germany. That's it. No need to put the error term there, automatically understood by the system. No need to put the coefficient B, D, F, no need. No need. Automatically understood. So leave it, LS, this square, leave it. The period, the full sample period. You want to change the period, just specify it. Q for quarter, just specify it. So we are following the full sample period. So you get the result like this. Result like this. So you have to transform the result into equation. So 0.42 is here. 0.4. There are so many decimal places in business and economics, of course, including finance, which are under business. Marketing management also under finance. You normally take 2 or 3 decimal places. If your paper has enough space, then you may take 3 decimal places. Otherwise, you may take 2 decimal places and consistently throughout the paper, or use the same decimal places. So let's say 2 decimal places. Germany, so a coefficient 0.22, another one 0.15, that one 0.48.
Đây hình dry review.
Okay. Any question there, class? All right. So that is how you transform the estimation into your equation. And this study, the variable that you want to predict or you want to estimate the value is Canada real interest rate. So the estimated version, you put a cap there like this, a caret there, to show the values are estimated. So whatever the value here, you just plug in and you are able to find the value here. Okay, so then what is the purpose of estimating? Number one, you know the impact. Okay, the impact. Number two, for prediction. What is the value? If Germany interest rate is 3, UK interest rate is 4, US interest rate is 3, what's the value? Just plug in and you calculate and get a value. So for prediction, for forecasting, modeling, we are doing the estimating, we are modeling it. Modeling and forecasting come together. So there are other aspects that we need to know from the result given to us. Okay. All right. Before that, interpret this coefficient. A 1 unit increase in this value, GER, is associated to 0.22 unit increase in CAN. So this increase, because of the positive relationship, this will also increase. So by how much? So let's say now the Germany, okay, interest rate is 3, and then when it increased to 4, that means there is 1 unit increase in this Germany. So what is the impact? Impact is 0.22. If there is a 2 unit increase, so this one times 2. 10 unit increase times 10. That is how you calculate the impact. So you say it's associated. Associated. You don't say that when Germany increase its interest rate by 1 unit, then Canada interest rate, it will cause Canada interest rate to increase by 0.22. Don't use the words cause. Don't use this word, because we are doing impact study. We don't know whether that is caused by the factors or not. We just show there is some relationship, association, to show whether this variable cause that variable or not. We do causality. Causality is is another topic in time series analysis. So that is one of the interpretation. Now the other thing we need to know is how good is our estimated model. How good? Then we look at R square. R square is here. This is R square. 0.9042. So this is times 100. You can get 90.42% of the changes in this dependent variable can be explained by the variation in other variables that you include in your ordinary least square estimation. So that means you put these are the factors. These are the factors that can explain 90.42% of the changes. So how do I want to know the Canada real interest rate? Then I have to look into the other 3 countries' interest rate, because from there I can know 90% of the changes in Canada real interest rate can be explained by the changes in other countries. The left about 10% not explained by these 3 countries, but may be explained by other countries or other factors. So normally we will look at a value of r squared is let's say 0.8 to say that your model that you estimate can explain the movement of the dependent variable well. Okay, well, the model is having good fit, we say. There may be other ways you can do a model whereby maybe your Canada, after you estimate, it is okay, different value. Maybe you don't want to include the US here, and you only include the other two countries, and you look at the R square. The R square may show 0.75. So these two countries, this interest rate or these two factors can explain 75% of movement of Canada real interest rate. So in that case, this model can explain better. So this model, that means you include the three variable, can explain better than these two variable. And sometimes maybe you put other things, other factors like GDP, money supply, other macroeconomic factors. So that's how you select your model. You consider different factors, different models. In the end, you choose the one that has the highest R square. The next thing that we need to interpret using our OLS result is, yeah, you say there is an association between this Germany interest rate and this Canada interest rate. All right, is that significant? Significant. Okay, do we have the significance impact? A significant impact. That means significant, let's say you're talking about your significance level 5%. That means 95% of the time when you see there is changes in the Germany real interest rate, it will also show changes in Canada real interest rate, 95%. So if you have got that, you say Germany real interest rate or any factor that you estimate here has significant impact on the dependent variable. So what do you mean when there is no significant impact? When there is no significant impact, let's say UK has no significant impact on the Canada real interest rate. That means we don't have to look at UK interest rate when we want to know Canada interest rate. It has no relationship with UK interest rate. So we forget about that UK. That is one way you can determine the variables as significant variable or not, important variable or not. So when we do a study, the factors affecting purchase intention, for example, and you put several factors from some theories, and then after that, some of the factors, when you estimate it, it shows it has significant impact. Others shows no significant impact. So those no significant impact factors that you have considered are not the determinants of the purchase intention, for example. That's how you select. Okay, so we call individual significance. We need to do the t-test. T-test, we have mentioned that in previous discussion. Okay, we can have now hypothesis say there is no significant impact, and alternative says there is a significant impact. Significant impact. So let the alpha be 1% or 5% or 10%. You are the researcher, you decide how many percent. So decision rule, reject hash down if P divided by 2. This P has to be divided by 2. You make a note because significance test is saying both sides. Okay, it has no negative impact. It has no positive impact. So it is two-tailed test. Two-tailed test. Now the p-value is 0.0376. So you have to divide it by 2, which is about 0.019. And you compare with alpha, that is less than alpha. Okay, so p divided by 2 is less than alpha. Reject the null hypothesis. Reject the null hypothesis. And so the conclusion is it has a significant impact. Okay, it has a significant impact on this variable. That means whenever Germany changes the data, we don't say whenever, most of the time. Let's say 95% of the time when Germany changes the real interest rate, then Canada will also changes the real interest rate. By how much? By this much impact. Okay, so we have said just now, we cannot say this factor cause this factor because we are not studying causation here. We are just studying association, studying the impact. Okay, so there are more about this ordinary least square. When you want to do that, we will have to, or you will have to study more into other detail. For example, one aspect that you should take care is, as we said, this ordinary least square, you can use it for time series data, you can use it for cross-sectional data, no problem. But you have to look at your variable. Your variable. We study that our variable can be categorical variable, which is qualitative variable. Our variable can also be quantitative variable. All right. So if you have all the variables, quantitative variable, you can do as usual. If your variables have category, then you have to do different treatment, not the ordinary specification like this anymore. Now, there are two kinds of situation. One is your category is in your dependent variable. This one is category. Category, the ordinary variable. Let's say you are modeling the failure and the success of the small and medium industry. What are the factors? So you put all the factors here, and here is success or failure of each of the SME. So that is categorical variable. You have to do different ways of OLS. The name is itself normal. OLS is some other name. Okay, so that is different topic. Now, most of the time we do have our dependent variable, which is quantitative. Okay, quantitative, and so sometimes we have another variable, which is category. For example, this is the crisis, the COVID crisis. All right. So in your time series data, 2018, 2019, consider there is no crisis, so you have to put a dummy variable 0. So this is a dummy variable that has only two values, 0 or 1. Okay, 2021, 2022, 1. So you have a dummy variable. You have to have dummy variable. Okay, so sometimes your dummy variable has more than two classification. For example, if you use category, we have discussed in other topics about Likert scale. There is one type which is called fully anchored. 1, 2, 3, 4, 5. They are having a definition for each of the scale. Let's say strongly disagree, disagree, neutral, and this is agree, strongly agree. This is fully anchored Likert scale, and you call this ordinal level of measurement, which is category data. So there are 5 classes here. So you got to have 4 dummy variable. So each one has 0 and 1. That is more complicated. So we don't explain it here. All right. But if you use the endpoint anchored, 1, ask the respondent to rate. 1 means strongly disagree, to 5 means strongly agree. So you have interval data. Then you can just add in that interval data here. No need to have, because it is not category. So you don't have to treat it as categorical independent variable. No need. So you can do as usual. All right. But the situation is many students define their options this way and they do all else, and that part is a problem. And then the whole analysis is no more valid. So you have to take care when you do it. Make sure you check it out. Check it out. There are different types of least square estimation with different data quality that we have, different measurement level that we have. Okay, so class, that's about ordinary least square.